Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform. Let me check the things. So I welcome you all to this platform of Unacademy. Okay, audio is good. So yeah. Hello Indrajit. Hello everyone. So in this class, we have already seen a lot of previous manufacturing class we have attended. So I will tell you what we are going to do in this class also. This So I welcome you all to this amazing platform of Unacademy. You know about me, but this is a brief introduction about myself. My name is Vidyapati Kumar. I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University. I have worked at CSIR Central Institute of Mining and Fuel Research. I have qualified GATE twice, and I am the author and co-author of various research papers which you can find on net. If you have a keen interest about the research works, you can feel free to check my research works. So this is a third part of the analysis of metal cutting. This lecture is actually the continuation of the analysis of metal cutting. In this we are going to see some of the brief specific cutting power and these things, some terminologies. We are going to see what is the dynamometer and these things, as well as we are going to see solve a lot of previous questions to get a good insight and feel to solve the GATE questions and ESE. So you can download the Unacademy Learning app. If you have downloaded the Unacademy Learning app, at this Unacademy Learning app, I take strength of material, and tomorrow also I will be taking a strength of material at 11 a.m. and the duration of the class would be 2 hour. Okay, so duration of the class would be 2 hour, and within a one month I am going to complete the entire strength of material with the various PYQs, concepts and everything. I'll try to wrap up this strength of material within 1 month. Okay, so please be happy with that. And so there is a benefit of the Unacademy Learning app. There is a daily live classes, structured courses are there, tests and quizzes are there. You can attempt a lot of multiple tests and quizzes. Unlimited access are there. So you should download the Unacademy Learning app. And if you are planning for a plus subscription where complete coverage of your entire mechanical syllabus is going to be covered, and in that platform there are a lot of top educators and they are going to guide you throughout the GATE preparation as well as ESE preparation. So the benefits are daily live classes are there, so you have opportunity to interact with your teacher, with your educator, and ask the multiple questions whichever you desire and whichever is their problem. So next is the structured courses. So you can make the structured courses. There is a lot of structured courses, so you can study strength of material in chronological order, heat transfer, fluid mechanics. Every subject would be there and complete coverage would be there. So if you are planning for a plus subscription, please do it because it is worth it. And these are the top educators in this platform, as well as GATE and ESE have a lot of umbrella. In this umbrella there are a lot of subjects and a lot of domains are there. So Unacademy provides the lectures for mechanical, CS, IT, general aptitude, mathematics, production, industrial, everything. It covers from tip to bottom. And if you are planning for the plus subscription, these are the minimum amount, that is 5,000 for 1 month, 3,000 for 3 months, that will be 12,500, and for 12 months that would be around 25,000. But if you will use my code SIRVK, then you will get a 10% discount and the discounted amount would be 22,500. So that is something around, you have to invest 60 rupees per day. So I think that is worth it to invest on your career, to invest on your future. Next is for a 24 months plan, it would cost around 30,000. So if someone who is in second year or third year, they can opt for this course and they will apply SirVK, then you will get a 10% off, and it will cost around 37 rupees per day. So what I want to say, if you are planning to go for a plus subscription, please use this code SirVK, and by using this code you will automatically be redirected to my mentorship, and I will guide you throughout your gate preparation. Okay, so let me check the comment section once again. Yeah, good evening to everyone. Okay, Asis. Actually, I will make it soon a Telegram session. I haven't made any Telegram channel also, so I will make it. And good evening, Nishant. Okay, so so in earlier classes we have seen this merchant circle, right? This merchant circle in which this is a tool, this is a reference plane, this is a shear plane, and this force is Fs. There is another force that is Fn. This is the resultant R. This is a frictional force F. This is normal to the frictional force N. And they are making some angle beta. They are making some angle beta. So this angle is beta, which is friction angle. And another, there is a cutting force. This is the cutting force. And in this direction, the thrust force, tangential force, Ft is acting. So now today in this class, I'm going to introduce some of the key things, that is about the power. See, when we are machining, there are a lot of forces that comes into play. Okay, so as we have discussed earlier, there are a lot of forces that comes into play. Please listen to me. There are a lot of forces that comes into play. So basically there are two types of machining. First one is orthogonal machining, and the second one is oblique machining. Okay, now for orthogonal machining there are only two types of forces. What are the forces, sir? That is the cutting forces and the thrust forces. And for oblique machining, for suppose a turning process, there are three type of forces, that is the cutting forces, and tangential forces has a two component, that is radial force and the axial force. Okay, so let me write it here. So if you talk about the orthogonal machining, then you have two forces, that is Fc, cutting force, and Ft, that is thrust force. And when it is oblique machining, then in case of oblique machining there are three types of forces, right? There are three types of forces. So that forces are, first one is Fc, and Ft has a two component, that is Fa and F. This is the axial force, and this is the feed force. This is also known as feed force, and this is your cutting force, and this is Fr, that is radial force. Okay, so basically these type of forces are there. Okay, and I have also given you the conversion formula how you can convert how you can convert how you can convert the ORS system to ASA and vice versa. Okay, so these things are clear to you. Okay, so having known these things, power, see, primary cutting force, that is FC, is acting in the direction of cutting velocity, right? So suppose when you are machining, in this direction the cutting velocity is there, and in this same direction the cutting force is responsible for entire cutting process, right? And this force is liable to cut the chips, to machine the element. So this primary cutting force FC is acting in the direction of cutting velocity, and this is the largest force, accounts for 99% of power required for the process. So let me clear it out. Sir, when you are applying, a lot of forces are there, sir. You know that in the machining there are forces, and among all the forces, this FC, that is the primary cutting force, accounts 99% of the power. 99% of the power. Now this 99% of the power is accountable due to the cutting force. So maximum force among all the things is FC. Now see the formula. The formula of FC is nothing but power. Power is equal to FC into cutting velocity. Okay. So cutting velocity can be written as FC is equal to pi d n by 60. Fine. So this is the basic formula of cutting power. Okay. Basic formula of cutting power. And see, if this cutting power has a unit of Newton, okay, and this V, cutting power, is suppose Newton, cutting velocity is suppose Newton meter per second. Okay, so Newton meter will be what? So see the unit, Newton meter per second. So Newton meter is going to be joule, and joule per second is nothing but watt. Clear? So this is the unit. So I hope these things are clear to you. Now see, next force that is associated with the oblique machining is FA. So FA is known as axial force or feed force, which is acting in that direction of tool feed. Okay, and it accounts 50% of the cutting force. Okay, this accounts only small percentage by tool power due to small feed rate. So the formula associated with the power of this feed power, better to say this feed power, so let me write it. So feed power is nothing but axial force, right? Axial force into Fn by 60. Axial force into Fn by 60. Sir, this axial force is also known as feed force. Okay, so do not confuse with that. And next most important thing is F and N, right? So the unit of F and the unit of N. The unit of F is mm per revolution, and unit of N is revolution per minute. So this is the basic formula of feed power. Clear? This is the basic formula of feed power. Now the another force is that is associated with it is radial force. During the turning process, the next force is associated, which is radial force. So radial force is equal to 50% of FA, that is 50% of feed force. So suppose if I have a feed force of 100 watt, 100 Newton, then the radial force is going to be 50 Newton, correct? And it is 25% of FC. It is 25% of cutting force, and hence contributes to very little power requirements. So if these things are clear to you, there is a very good relation that we have got, that is, sir, and that relation is this. So cutting force is always going to be greater, right? Cutting force is always going to be greater. Next force that is greater, that is smaller, next immediate smaller than the cutting force is Fa, and Fa can also be written as feed force. Let me write it more explicitly, because in questions sometimes instead of axial force it is mentioned the feed force. So you have the tendency, you should have a tendency to think about that. Okay, so this is actually feed force. So this is a good relation that you should keep in your mind, that always and always, sir has told me that always and always cutting force is going to be greater, after that axial force would be there, and after that radial force would be there. So I hope these things are clear to you. Next thing that I'm going to discuss is power consumed during the machining process. Power consumed during the machining process. Now see, what are the power consumed during the machining process? See, when you are machining, let me draw it here. So when you are machining, see what are the things that is happening. See, in this direction, the chip velocity Vc would be acting, okay? And in the same direction, the frictional force is also acting. Next is, in the same direction, the cutting force is acting, and also the cutting velocity is acting, and the cutting force is also acting. Clear? And in this shear plane, see this is a shear plane. So in the shear plane, the shear velocity is also acting here, and also the force associated with the shear velocity, that is the shear force, is also acting in this direction. So if I would say, sir, what is my shearing power? What is my shearing power? So shearing power is nothing but shearing force into shear velocity. Clear? Next thing is, what is my frictional power? What is my frictional power? So my frictional power is going to be F. I'm sorry. So this is F, right? So this is F. So frictional power F into Vc, that is the chip velocity. Okay. Now see, main power. If I would talk about the main power is your Fc into V, because this is the main cutting power, right? This is the main cutting power. So if I would write that, therefore total power is going to be equal to shearing power plus frictional power. See, when you are giving the force, when you are giving the cutting force, that is the main power is being given by you to the machine element. Now when you have given that cutting force, then cutting power is there. So main power is Fc into V, and due to this main power, there is the associated power that comes into play, that is the shearing power, and the frictional power. So total power is going to be, F FC, that is cutting a force, into V. Okay, and this is also equal to shearing power. So see, shearing power is Fs into Vs, Fs into Vs, and frictional power is F into Vc. So this is the relation that is you have found out. Now in questions, now in GATE previous year questions, if you can see, what are the way of questions being asked in this area. Please see, they ask that please find the percentage frictional power. Please find the percentage frictional power. So what would be the percentage frictional power? Percentage frictional power is going to be your frictional power, into by total power into 100. So which is nothing, frictional power. What is frictional power, sir? Frictional power is F into Vc, and this is going to be equal to Fc into V. This is 100. So this is the value in percentage. So this is the one relation that we have got, frictional power. So how we can find the frictional power? This is the relation. Next question that is asked is, this: percentage of shearing power. So what is the percentage of shearing power? That is nothing but shearing power, divided by total power. Okay, and this is equal to, what is the shearing power? So see, shearing power is Fs into Vs. So you can write Fs into Vs. Total power is cutting force into cutting velocity. This into 100. Okay, so this is going to be in percentage. So these are the two relations that you have got. Okay, so into 100 you can write here into 100. So these are the two relations that please remember, equation 1 and equation 2, and these are the forces. So I hope power consumed during machining, during the entire machining, what are the power consumed, and how you can find the percentage frictional power and the percentage shearing power. So these things are clear to you. So if you have any doubt, then please ask me. If you have any doubt, then please ask me. Okay, fine. So everything is clear. Next important topic is specific energy consumption. See, what is specific energy consumption? So specific energy consumption, which is denoted by small e, so it is defined as power by MRR, power by material removal rate. So power by material removal rate, it is being defined, right? Now see, what is power? So we know what is power. So main cutting power, right? So main power is your Fc into V. Just now we have seen cutting force into cutting velocity. That is the main power, right? If somebody is asking you that in question, if it is mentioned that blah blah blah, everything is there, and you have been asked to find the power, so you have to assume that examiner is asking about the cutting power, because we have seen 99% of the power consumption is due to this, right? Due to the cutting force. So I hope these things are clear to you. So power is going to be Fc into V. Clear? And we have seen the MRR, right? Material removal rate, that is written by DFV, where D is the depth of cut. Let me write it here, where D is the depth of cut, F is the feed rate, V is the cutting velocity. V is the cutting velocity. Okay, now see, this V get cancelled out, so you are left with only Fc by Df. Clear? Fc by Df. Okay, now please analyze the unit. So this is the formula. This is the formula. This is the formula of specific energy consumption. Now see the units. What would be the units? So that is FCDF. The unit of Fc is Newton. The unit of D is mm, and the unit of F is mm per revolution. So you are left with Newton millimeter square. Now, since it is defined as energy, so we must convert this in terms of joule, okay, so that there is a proper logical reason. So see, if I would see that Newton meter and meter mm square, divide and multiply by meter, then this meter can be converted to millimeter square by multiplying 1000. So this is why you can multiply 1000 here, and your unit is going to be, now Newton meter is going to be your joule, and this meter would be your millimeter square, millimeter, because you have already compensated the 1000 for that, hence that would be joule per millimeter cube. Okay, so this is the your unit. So the unit is going to be joule per millimeter. Okay, so I hope this is clear. Specific energy consumption is clear to you, and how the units are there for specific energy consumption, these things are clear to you. Now see, next part is specific cutting pressure. Now see, what is a specific cutting pressure? See, when you are machining, so in this plane actually, right, uh, see, just a little bit, I'm just drawing. See, in this plane actually, whatever the pressure is created in this plane, this is actually specific cutting pressure. Okay, so see, what is specific cutting pressure? This is nothing but it is defined as force cutting force divided by area of undeformed chip thickness. Okay, now see, cutting force is what? Cutting force is Fc, and area of undeformed is what? This is going to be your B. See, this is your B width. Okay, and this is your T. This is your T. So the area of undeformed chip is going to be your B into T. Clear? This is the area that is undeformed. See, this particular area is your undeformed, right? So this is Fc into Bt. Okay, now see, in earlier class I have told you that what is B. B can be written as D by sine lambda, and what is the T? T can be written as F sine lambda, right? So this is the two relations that I have told you earlier also, where lambda is what? Approach angle. So when you would put it these things here, right, in place of b, d sine lambda, right, see here, that is your f by b would be d sine lambda into t would be f sine lambda. Then this sine lambda will get cancelled. Okay, this will get cancelled, and you are left with nothing but this f by df. Okay, f by df. So you just remember that specific cutting pressure is equal to cutting force by area of undeformed chip thickness, which is nothing but f by f by df, f by df. Okay, so till now, if you have any confusion, if you have any doubt, then please ask me, because this is what is the main concept in this analysis of metal cutting. If these things are clear, how the powers are coming and how the things are going on, then you would be good to go to solve any problems. Okay, now next problem, next thing is dynamometer. Next part is dynamometer. Now see, when I was telling you, when I was introducing you the the merchant circle diagram in the earlier classes, I have told you that there is a device, there is an instrument that is used to measure the cutting forces, right? Now what is the cutting forces, sir? There are actually two types of cutting forces, right? So basically we say primary cutting forces, fc, and tangential cutting force, that is thrust force. We say that it is a thrust force. So basically dynamometer are used to measure the cutting forces. So first point, it should be clear to you, that should be in your mind, that sir, dynamometer, the function of dynamometer is it is used to measure the cutting forces. Next is, sir, for orthogonal cutting we use the 2D dynamometer. We have also discussed that why orthogonal cutting has we have seen that orthogonal cutting has only two-dimensional forces are there, right? Only two components of forces are there, and hence it is also known as 2D machining, right? 2D machining, and hence to measure the 2D forces we require the 2D dynamometer. Similarly, for oblique cutting we requires the 3D dynamometer. If you have any doubt, then please ask with me. Okay, otherwise I am proceeding, right? Okay, so this is the basic funda of dynamometer, and if these things are clear to you, then please try to give me the answer of this question. Okay, the instrument or device used to measure the cutting forces in machining is what? Please tell me the answer. Very easy problem is there. Okay, see, very easy question is there. Instrument or device which is used to measure the cutting forces, that is dynamometer, right? So we have the two answers from Mukta and Asis. Great, great, good. Indrajit, Shivam, Subham, good. Study with me, and I can assure you, you will be able to solve a lot of questions from your own. Okay, at the end of the session I will ask you one question, and please give me the genuine reply. Okay, now see, please solve this question. ESE 1993. A dynamometer is a device used for the measurement of what? Tell me. Tell me. Okay. We have the option from Mukta, that is B. Yeah, that is B also. Okay. There is no need to you should not take even more than 2 seconds or 1 seconds, because whenever you are saying, sir, there is a dynamometer, so the function of dynamometer is to measure the forces during the metal cutting, so answer is going to be B. right? And why, Syam, why it should be wear of cutting tool? Have I told anything like wear of cutting tool? Okay, Syam is late. Okay, okay, I can relate with him. Okay, fine. He is giving the answer of earlier question. Now see, please try to solve this question. These questions are very amazing. These questions would clear your all doubts, your all problems. And believe me, the question set that I am giving to you, when you will be able to solve this all questions, I guarantee you there would be no questions in the metal cutting chapter that will be stopping you. Okay, that will be stopping you. Okay, so when you will please try to solve these questions. All the question sets are very fine. Questions are very fine. These questions will clear your concepts, and you will be able to solve any questions in GATE. You are good to go. Good to go. Okay. मैं आपको बहुत प्रैक्टिस करवा रहा हूँ, बहुत ही ज्यादा प्रैक्टिस करवा रहा हूँ, ताकि आपका कुछ भी ना छूटे. ठीक है, चलिए सॉल्व करिए इसको. प्लीज ट्राई टू सॉल्व दिस. ऑप्शन इज डी. Asis has given option as D. Okay, let me check Asis. No, Asis, please check your answer. No, please check your answer. Don't be in a hurry. I'm giving you 2 minutes. Don't be in a hurry. For those who are not understanding the things, for those I am just telling the things, this is orthogonal turning, right? So this is the orthogonal turning. Clear? So it has been observed that the friction force acting at chip tool interface is 402.5 Newton. So what is the friction force? So F is going to be your 402.5 Newton. Now see, and the friction force is also perpendicular to the cutting velocity vector. If you could remember what I have told you in earlier classes, that if friction force is perpendicular to the cutting velocity, that simply means that if friction force is perpendicular to the cutting velocity, that simply means alpha is going to be 0. Kindly check the special cases that I have mentioned to you, right? So in that cases, alpha is going to be 0. That is, the rake angle is going to be 0. Clear? Next is the feed velocity is negligibly small with respect to the cutting velocity. The ratio of friction force to the normal force associated with the chip tool interface is 1. Now what is 1? 1 is ratio of friction force. So the ratio of friction force is F by normal force, that is N. This is defined as mu. This is nothing but tan beta, which is equal to 1. Clear? Next is the uncut chip thickness is 0.2 mm. So uncut chip thickness. Uncut chip thickness is 0.2 mm. That is T. Chip thickness is 0.4 mm. So that is TC. TC is equal to 0.4 mm. The cutting velocity is 2 meter per second. Next point that is given as cutting velocity is 2 meter per second. Find the shear force. You have to find the shear force acting in the primary shear zone. So see what are the data that has been given. First thing is your frictional force is given, right? So it is, this data implies that alpha is going to be 0. Again, this is given. Next, uncut chip thickness is given. Chip thickness is given, and your cutting velocity is given. So these data are given to you, right? Now it has been asked in question to find the shear force, right? So the shear force would be, so what would be the shear force, that is Fs. Please try to solve it. Okay, again another hint, you just consider one thing, you just make the merchant circle diagram very fast. This is your R, okay, this is your Fc, okay, this is your Ft, next is this is your Fs, and this is your Fn, next is your F, and this is frictional force, right? And this is your normal to the frictional force. This is beta, this is phi, right? And there is a tool, here, so this angle is beta minus alpha, right? So these things are clear to you. Now please try to solve this question. There is nothing so much hard about it. Still now I haven't received any question, any answer. Are you filling the problem to solve this question? Then please do let me know. Otherwise, don't waste the time. Okay, fine. So I have given a lot of. Is it A? A is what? Yes. Yes, correct. Asis, correct answer is A. Yes, Asis, the correct answer is going to be A. Okay, see. See, these things are given to you. What you can do. Now see, I am writing the step-by-step things. Step 1. Step 1. Step 1 would be, see, alpha is given as 0. Okay, so alpha is 0. You have been given R and you have RTC, then find the R. Find the R. Okay, and you have alpha is equal to 0, then you can find step 1, that is phi. And how you can find the phi? You can find the phi with the help of this formula. Okay, tan phi is equal to R cos alpha by 1 minus of R sin alpha. Clear? So this is the first step that tells to find the phi. Next step is to find the beta, that is the friction angle. How you can find the beta? That is tan beta is equal to 1. So the formula associated with this would be tan inverse 1 is going to be beta, that is 45 degree. Clear? So this is the second step. Now see in this figure, sorry, now see, when you can see in this figure, see in this figure, what is F, or better to say, what would be R? How you can find the R? So you know F, you know N, because see, F and N both are equal to 1, that is F and N both would be same, that is F is going to be 402.5. so step 3 is going to be to find the value of R. And how you can find the value of R? You can find the value of R, very simple is there. R would be is equal to F square plus N square. Okay, and this is nothing but R is 402.5 whole square plus 402.5 whole square. So from here you can find the value of R, because see, both are equal. F is equal to N, both are equal to 1, right? So the value of f is given, the same value would be of n. Now once you have find the r, step 4 would be step 4 would be to find the shear force, right? To find the shear force, how you can find the shear force? See, this is the angle, this is the angle. Okay, so can you write that shear force is nothing but fs is equal to r cos of beta minus of alpha plus of phi? Okay, beta minus of alpha, this is the one angle, beta minus of alpha. See, this is beta minus of alpha, beta minus of alpha, and this is phi. So adding them, you would get this formula: fs is equal to r cos of beta minus of alpha plus of phi. From here you will get the value of fs. So Syam Babu has found the value of a. Okay, r is equal to 0.5. Okay, fine. So I hope this is clear to you, or should I solve in more details? Please let me know. Everyone, when you would use these things, you would get the answer. Okay, and if still you have any doubt, then please do let me know. Otherwise I will solve from each and every step. Okay, 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 fine. So I got your reply that these things are clear to you. Now if these things are uh, fs is equal to fc cos phi plus ft sin phi. Okay, no problem. And you got the result. Nishant has told that he will try. Okay, Nishant. Okay, okay. See, I'll just write everything. See, first step is r. See how you can find the value of r. That is, see here, that is a 0.2 and a 0.4. 0.2 by 0.4. That is nothing but 0.5. Clear? So how you can find the phi? Phi is going to be tan inverse of r. R is what? 0.5. R cos 0 degree by 1 minus of r sine 0 degree. So from here you will get the value of phi as 26.565 degree. So this is the value of phi that you will get. Now second step, what I have told, that tan inverse beta, oh sorry, mu is equal to tan beta, which is equal to 1. So from here beta is going to be tan inverse of 1, which is nothing but 45 degree. Clear? The third step would be, what I have told you, to find the value of r. So r would be what? F, see from this figure, right? F and n. If you would draw the merchant circle, this is going to be your r, this is going to be your f, and this is going to be your n. And see, since mu is equal to f by n is equal to 1, so f is equal to n. Both value are going to be same. So f square plus n square, this is going to be there. And see, the value of f and n is given as 402.5. So 402.5 square plus 402.5 square, and if you would calculate this value of r, you will get this value of r as 569.22 Newton. Clear? And the fourth step that I have told you, that fs is going to be, see, this is your fs, see, this is your fs, okay, this is your fn, and this angle was beta minus alpha, and this phi angle was there. See, this beta minus alpha, and this is a phi. Okay, so from here what you can write, fs is equal to r cos of beta minus of alpha plus of phi. And when you will plug these things, r is equal to 569.22 into cos of beta. Beta is going to be your 45 degrees, so 45 minus of r is your 0, so 45 minus 0 plus 26.565. And when you will solve these values of fs is going to be your 180 Newton. So I think I have solved everything. I don't find any problem here. So this is your r, this is your phi, this is your beta, this is the value of r, and this is the value of shearing force. Okay, great. Now please try to solve this question. Please try to solve this question. The same question is there. Okay, the same question is there, and with this question the data is same, but what is different is this. What is different is this. Okay, so assume that the energy expended during machining is completely converted to heat. The rate of heat generation in watt at primary shear plane is what? So they're asking about the rate of heat generation. Okay, that is, they're asking about the power. They are asking about the power. F is equal to N is equal to Fc is equal to Ft as alpha is equal to 0 and beta is equal to 45. Okay, please solve this question. Please solve this question. I am giving you some time, 2 minutes. Solve this question, and in middle of that I am also solving this so that I can tell you the answer. Mm, okay, sorry. Data, every data is same. Okay, so just the difference is there that you have to calculate the heat generation, right? And how you can calculate the heat generation? See, it is asked the rate of heat generation at the primary shear zone, right? At the primary shear zone. So what is the meaning of primary shear zone? So at primary shear zone there is the shear force and the shear velocity. There is shear force and shear velocity, and due to this thing only there is a heat generation at this shear plane. So you have to find the cutting power at by using this formula Fs into Vs. Okay, so I hope this hint is enough to solve the question. Please give me the answer. You have 1 minute. Asis, you have already found the shear force. See, this is the continuation. This is the linked question. This is the linked question. 2010 linked question set 1. This is the linked question. From here, from this question only, you have found the shear force as 180 Newton. So you are using those results in this question also. Okay, both questions are linked. So I hope this hint is enough. Okay, so Asis has given option D. Okay, anybody else? We have got the answer as D, 402.5 from Asis. Now see, there is nothing so much big about it. I have already told you, right? So there is you have to remember, is it option D, sir? Yes, yes, Asis, the correct answer is option D. For those who have tried and still they cannot find the answer, please see here. What is the relation between the velocity triangle? Do you remember the velocity triangle? Do you remember the velocity triangle? Do you remember the velocity triangle? So from the velocity triangle, I can write a relation as V by sine 90 minus of phi plus minus of alpha. This is equal to Vs by sine of 90 minus of alpha. Clear? So you know the value of V, you know phi, you know alpha. So from here you can find the value of Vs, right? So this would be Vs value you will get as 2.2361 meter per second. Okay. Yes, Asis, we have to use the velocity triangle. If you have any problem in the velocity triangle, then please do let me know. I will again explain the velocity triangle to you, and those things would be there. Okay, so from the velocity triangle, you can get the velocity as Vs is equal to 2.2361. Now see, for in the shear plane, the heat generation in the shear plane. So what you can write here, heat generation, heat generation at the primary shear plane, at the primary shear zone. So this would be nothing but Fs into Vs. Clear? Now what is Fs? Fs you have found out as 180 Newton. See this 180 Newton in this earlier question, right? And next what you have found as Vs, that is your shear velocity, that is 2.2361, right? So these two data are enough to find the heat. Okay, to find the heat. So 180 Newton what is going to be 2.2361 meter per second. So when you would solve it, you will get as 402.5 watt. So this is the shearing power. Okay, Shivam has also given the answer as D. Okay, so till now if you have any doubt, then please ask me. If you have any doubt, then please ask me. Yes, 402.492 in the G. Clear. Okay. So these things are clear to you. Kiran has told, sir, I don't get which power. Kiran, see, Kiran, see. This is a very good question. If you have a doubt, ask me. I'll clear it out. See, in this question, it has been told that rate of heat generation at the primary shear plane, okay, rate of heat generation at the primary shear plane. No, see, what is the primary shear plane, Kiran? See here, see, Kiran. I'm explaining to you. When you are machining, okay, so the chips get formed out, and with the tool. This is a tool, and see, this is a shear plane. So I have already told you there are two zones. There are two zones. One zone is this, and another zone is this, right? So this zone is known as primary shear zone, okay, and this zone is secondary deformation zone, okay. And in question it has been asked that you have to find the rate of heat at primary shear zone, at primary shear plane. So what is the primary shear plane? This is the primary shear plane, right? This is the primary shear plane, this is the primary shear plane, and in this primary shear plane the forces that are acting, the forces that are acting is the shear force, the shear force, okay, and the shear velocity, okay. So hence we are using the shear force and shear velocity product, and heat generation is there. So I hope, Kiran, it is clear to you. It should not be frictional, because here the frictional force comes into play, right? Here the frictional force comes into play, and this zone is secondary deformation zone, and this is primary shear zone, right? A zone where the shear takes place, the shear takes place, and at that zone, shear zone, the shear force comes into play, okay. So I hope this explanation is clear to you, Kiran, how to recognize the things, okay. Good questions. Now please try to solve this question. Previous year GATE 2007 question is there. So this is a very basic question. Friction angle has been asked. Friction angle has been asked. We have got answer A from Shivam, okay. Let me check A, let me check Shivam. Okay, okay, fine. Anybody else? Shivam has given the correct answer. Wait, okay, Mukta, I'm giving you some time. Asif has told 22.61. Okay, good Asif, good. And I'm telling you, I have started strength of material at the Unacademy learning app, and I'm going to complete the strength of material in that app, and manufacturing in this YouTube. So if you want to study with me, study in both the platforms, and after the strength of material I'll start any other subjects also, okay. So A, Indrajit has told A answer, okay, fine. See, very easy. Cutting force, so this is FC. Thrust force, so this is FT. Rake angle is 0, that is alpha is equal to 0. Cutting speed is 1 meter per second, that is V is equal to 1 meter per second. Depth of cut is pointed, that is D is equal to 0.8 given, clear. And chip thickness is given as 1.5, that is chip thickness is what, TC is equal to 1.5 mm. Asis, I have already extended the duration in Unacademy app also. Tomorrow the class will be of 2 hours, okay, and in near future I'll try to increase the timing from 2 to 3, that is in terms of 2 plus 1. I'll take a class of 2 hours, after I'll give a break to you, and then I will take a class of 1 hour also. So I can take it, but from today onwards all the class will be of 2 hours. Okay, so there would be no 1 hour classes would be there, and if something urgent happens to me, then I'll take a 1 hour class. That's not a hard and fast, but most of the classes would be of 2 hours. I have a target to complete the strength of material within a 1 month. Okay, so don't worry. Okay. Okay, see here. So these things are given to you. Okay, and they have been asking that what is the friction angle. So how you can find the friction angle? Already a lot of people has given me the correct answer. So there is a relation that F is equal to Fc sine alpha plus Ft cos alpha. Alpha is 0. Okay, alpha is 0, so cos alpha, cos 0 is 0, and sine 0 is finished. So F is going to be equal to Ft. Clear? F is going to be equal to Ft. So what is Ft? Ft is 500 Newton. So this is 500 Newton. Now next equation is, this is the equation 1. Next equation is N is equal to Fc sine Fc, sorry, this would be cos alpha minus of Ft sine alpha. Now put alpha is equal to 0, then N is going to be your Fc. Okay, so when N is going to be your Fc, that is going to be your 1200 Newton. Clear? Now see, you have got the value of F, you have got the value of N. So what is the friction angle? Mu is equal to tan beta, which is equal to F by N, which is nothing but F is equal to 500 by 1200, right? So this is going to be equal to, beta would be tan inverse of 500 by 1200, and this is going to be 22.6 degree. Clear? Yes, yes, yes. Tan beta equal to F by N will be one step method. Yes, yes, this is the way, but I am explaining in more details. Okay, correct, Mukta? That is definitely. See, if I will be solving this question, then see, these calculations is in my mind. See, these calculations are in my mind. These things I do not have to do in pen and with help of pen and paper, because see, I know that okay, F is equal to this, so this would be the relation that cos alpha is going to be 0, that is 1, and sin alpha is going to be 0. So this is F, this is N, and just I will put in the calculators, and with the help of that I can solve it. So yes, good approach is there. Fine. Next, you solve this question. Next, in this same question is there, the thing is that they are asking about the chip speed along the tool rake face. Chip speed along the tool rake face. Tell me, what would be the chip speed? What would be the chip speed? Now you do not, please do not confuse with the chip speed. What is the meaning of chip speed? What is the meaning of chip speed? Chip speed means VC, right? Chip velocity. Chip velocity. And if you have any doubt, then please ask me. Okay, and solve this question. Chip velocity. How you can find the chip velocity? Shivam has given the answer as 0.53. Okay, Shivam, good. I'm giving you some more couple of times. Unacademy ऐप पर एक बहुत अच्छा features है polling का. If that polling option would have been in this YouTube, then that would be awesome for that. That would be really helpful to take a polling from you, and sometimes would be saved also. Okay, see, I have given you enough time. See, this is orthogonal machining. This is orthogonal machining, right? So orthogonal machining is there. So you know that orthogonal machining is there. That is T is equal to F is equal to D. Clear? Always keep in mind. Always keep in mind that D is what? D is your depth of cut. F is what? Feed. D is what? Uncut chip thickness. Okay, so whenever there is orthogonal machining, just remember T is equal to F is equal to D. Okay, now see, it has been given that where is the chip thickness is given as 1.5 mm, so TC is given as 1.5 mm. Clear? And where is the depth of cut? Depth of cut is 0.8 mm, so T is would be 0.8 mm. Clear? Because T is equal to is going to be equal to depth of cut. Now see, R is equal to T by TC. Clear? And this equation is also is equal to VC by V. Remember the first class. Remember the first class in the first maybe in fourth lecture I have told you these relations. Okay, so T by TC. What is T? T is going to be your 0.8. TC is going to be your 1.5. VC, you have to find VC, and V is given as 1. Okay, so from here you can find as 0.53 meter per second. Clear? So we have got a lot of B options, so good. I'm really happy you are giving the correct answers. Now please find this question. Please find the answer of this question. In this question, shear angle and shear force has been asked. Remember the formula of shear angle? How you can find the shear angle? From that the ultimate formula. And the ultimate formula is what? Tan phi is equal to r cos alpha by 1 minus r sin alpha. Right? So give me the answer. Please share these videos also, so that whosoever are preparing for the GATE, they will be eventually benefited with my lectures, and they will really learn a good manufacturing concepts from me. That's what I can guarantee you. Okay, Asis has given option B. Okay, let me check Asis. Okay, correct. Syam has also given the B answer. Correct, Syam. Here B option. Yes, Asis, I have told you. Option B is correct. Shivam, option B is correct. See, in this question, what is being asked? Orthogonal machining is there, mild steel is there with a cutting tool of 0 rake angle. So you just write angle is equal to 0. Uncut chip thickness is equal to 0.5, that is T. Chip thickness is equal to 0.75, that is TC. Width of cut, that is 2.5, that is B. Normal force, that is N. Thrust force, that is FT. Okay, and you have to find shear angle and shear force. Mukta has also given the option B. Anybody else? So everybody has, almost everyone has given the option B. Okay, so fine. So these questions are very easy. Now please solve this question. Now please solve this question. If you have a doubt, then I will solve the entire questions. Okay, please solve this question. GATE 2011 question. Please solve this question. Both the questions are, see, both the questions are linked. Okay, so continuation of that, Indrajit has given option B. Okay, is it of okay, earlier question, right? Should I solve that earlier question? Please do let me know, and please solve this question also. Okay, if anybody has any doubt, then I'll solve it. Ultimate shear stress you have to find, right? Ultimate shear stress you have to find. You already know that shear force is nothing but ultimate shear stress into Bt by sine phi. We have discussed this formula, okay? Use this formula. Use this formula. Use this formula to find ultimate shear stress, right? This is your ultimate shear stress. We have option D from Shivam, okay? Correct, Shivam. Option D is correct. Three 380. Yes, okay, correct. And please do let me know that should I solve this question? Should I solve this question or not? 379.93. Yes, in the J D. Yes, correct. Everyone is giving me the correct answer. Good, good. See, there is nothing rocket science is involved. You have find the fs earlier, and the fs value is 751.04 newton in the earlier question. So what you need to do, you need to plug in the values in this equation. So see, fs is going to be equal to 751.04. this is equal to tau. You need to find the tau into b. What would be the value of b? B is equal to 2.5. see, width of cut, that is b. Okay, so b is equal to 2.5, and this is in mm. And see, this is the t is what? Uncut chip thickness, that is 0.25. so 0.25 mm divided by sine of phi. So what is sine of phi? In earlier question you have to calculate the phi, and the phi would be is equal to 18.435 degree. So when you would put 18.435, then you will get the answers. So from here, tau value is going to be equal to 379.90, which is roughly is equal to 380 Newton millimeter square. Okay, so this is the value of tau. Uh, okay, thank you, Sam. Please explain problems. Which problem you want me to explain? Let me know. Let me know. You want me to solve this question? You want me to solve this question? See, there is nothing so big in this. There is nothing so big in this. Just again, I'm running very fast. Okay, I'm just running this very fast. मैं बहुत जल्दी इसको करता हूँ. See, this is alpha, this is t, this is tc, this is b, and this is normal force, right? So this is given as n. This is given as n. So what you need to find? You need to find, first step is there, r is equal to t by tc. Okay, so t is given as a 0.25, tc is given as 0.75. From here you will get the 0.333. Okay, so this is the value of r. So from here you use the formula, that is tan phi is equal to r cos alpha by 1 minus of r sine alpha. So from here, when you will use this, and you will get the value of phi as 18.435 degree. 18.435 degree. Clear? So this is the first thing that we are getting. Phi is equal to 18.53. Next point is this: how you can calculate the value of shear force. So this is a shear angle, right? So this is the shear angle. First thing is clear. Now from the first option itself you can say that, okay sir, shear angle is 18.4350, so option B would be there. Okay, so you need not to solve anything else, right? यहीं पर आपका फिनिश हो जाता है. So at this point your option is done. But how you can find the value of shear force? So shear force value can be found out that Fs is equal to Fc cos of phi plus minus of Ft sin of phi. Clear? Now you know the value of phi, you know the value of Ft is this, okay? And since alpha is equal to 0, so this is going to be your equal to Fc. Okay, just plug in the values. Fs is equal to Fc, so you know that what is going to be 950 cos of 18.435 minus of Ft. What is Ft? Ft is 475, so 475 sine of 18.435, and from here you will get the values of approximately 751.04. So I hope everything is clear. So try to solve this question. Another GATE 2019 question is there. Fresh, hot, important question is there. Solve this. See, in manufacturing, what I have felt from my experience, if you really want to score a good marks in manufacturing, see, I'm not talking about that you score 15 marks. Okay, I do not care about the 15 marks. I care about, sir, if there is 18 marks from manufacturing, I want single marks from that manufacturing. I do not want to waste even a 1 marks, even a 0.33. I do not even want to make a negative at that subject, right? So that should be your level of preparation. That should be your level of preparation. So if you can prepare manufacturing, that is going to easily give you 18 to 20 marks, 18 to 20 marks alone. Okay, so it can give you the 18 to 20 marks alone. So prepare well, and see, again, strategy is there: 18 to 20 marks from manufacturing and 28 marks from aptitude as well as mathematics. So these from these also you are getting approximately 45 to 50 marks of preparation is there from this only three things. Okay, tell me the answer. One more minute, if you have 1 more minute, please try to solve it and tell me the answers. Same problem is there, but little bit language is changed, so you have to see the language. Okay, Asis has told 37.26. okay, 1 minute, Asis. How, Asis? How it can be 37.26? See, coefficient of friction cannot be 37.26. Don't make a silly mistake, right? Because this every mistakes count in your GATE examination. Every mistake counts on your GATE examination. Don't mistake it. Okay, so Indrajit has given the answer 0.736. Correct. See, in this question, rake angle is given. Okay, so rake angle is given, that is alpha is equal to 10. Uncut chip thickness is given, that is uncut chip thickness is what, that is T. Is and chip thickness are this. So uncut chip thickness is 0.125 mm, and chip thickness is given as 0.22 mm. So chip thickness is 0.22 mm. You have to, I have found something else. Okay, so why you would find something else, why you will find something else, as is in question only coefficient of friction is given, so you have to calculate only this thing, right? So first step, the first step should be R. So right, so you have to calculate R. So how you can calculate R? R can be calculated as T by Tc. Okay, T by Tc. Okay, okay, I understood, Asis. See, T by Tc, T is what, 0.125, Tc is 0.22, you will get the value of R. Next is tan phi. Tan phi is equal to R cos alpha by 1 minus R sin alpha. So from here you can calculate phi value, okay, because alpha is 10. So 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 phi would be tan inverse of R. R is 0.125 by 0.125, it should be 0.5682. This is 0.5682. Let me write it here. This is 0.5682. Okay, so 0.5682 cos alpha. So what would be the cos alpha? Cos 10 by 1 minus of 0.5682 sin 10. And when you will solve it, you will get the value of phi. Phi is going to be equal to your 31.83. Clear? 31.83. Now see, once you have found the value of alpha is 10, phi is 31.83, and in question it is given using merchant first solution, so everything is given to you, so you have to use the merchant first solution. So from merchant theory, so from merchant theory, what you can do is 2 phi plus beta is equal to 90 plus alpha. So from here you will get the value of beta, right? So you just put the values and you will get the value of beta as 36.34 degree, and mu is equal to tan beta, right? So mu would going to be equal to tan of 36.34, which is nothing but 0.7356. Clear? Okay, I don't think you have any doubt, and even if you have the doubt, please ask with me. Okay, please write these solutions in your notebook also, and try to solve this question. Previous year GATE 2006 paper. This is again the previous year GATE 2006. Every question is from mechanical and production. Okay, solve this question. See, uncut chip thickness is given. Okay, I'm giving you 2 minutes. Solve it. If you have any problem, then please I will explain it. You have to find the shear angle and shear strain. Okay, good. 0.73. Okay, you have given the answer of earlier question, Syam. See, very easy problem is there. See, I'm explaining a little bit so that you can solve this question. Uncut thickness is what? Uncut thickness is T. Cutting speed is what? 20 meter per minute. Okay, just keep it aside. Rake angle is given as 15 degrees. So this is what? Alpha. Next is width of cut, that is B. Chip thickness is 0.7 mm. So this is your TC. Okay. Now see, you know TC, you know T, you know alpha. So can you find it? Can you find this? R is equal to T by TC. Fine. So your T is what? 0.5. Your TC is what? 0.7. So R is going to be equal to 0.714. Okay, so that is equal to 0.714. Now what you can do, you can find the value of phi. How you can find the value of phi? You can find the value of phi as tan phi is equal to r cos alpha by 1 minus of r sin alpha. Okay, okay, so I have got some options as D. uh, why it should be option D? You are getting option D? Please check your answers. See, so tan phi is equal to r cos alpha by 1 minus r sin alpha. So from here, you will calculate the phi, right? So you would get phi as this is your, okay. So sin 15. So the phi value that I am getting is 40.245. Okay, so this is the phi value that I am getting. Now Mukta is telling me the answer C. Please check your answers. I request you everyone to check your answer. So see, so first I have got the value of r as this, phi is equal to this. So I have phi value as this, rake angle is this 15. Okay, now it has been mentioned in the question, assume merchant's theory. Assume merchant's theory. So what I can say, merchant theory, I have to assume the merchant theory. So from the merchant theory we know that, you know, 2 phi plus beta is going to be equal to 90 plus of alpha. Clear? Now you have to calculate the beta. Beta is equal to 90 plus alpha minus of 2 phi. Okay, so one minute. Why you are giving the options D? Please check your answers. See, you have a phi, you have alpha, you can find the shear strain. You can find the shear strain. You can find the shear strain, right? Formula is cot phi plus tan phi minus alpha. Clear? So cot of phi, that is phi is 40.245 plus tan of phi, that is 40.245 minus of alpha. Alpha is given as 15, so 1.65. Okay, so when you would calculate cot of phi, so cot of phi is what? 40.245 plus tan of phi is 40.245 minus of alpha. Alpha is given as 15, and when you will calculate these things, then you will get the values as 1.65. Okay, okay, clear? So the option should be this. Okay, D. See, Shivam, Mukta, everyone. See, I also do not have the answers of this question, so sometimes there is like problem is there. So that is why I have told you that D may not be the option. Okay, so I think this concept is clear to you. This logic is clear to you, how you can find these things. And the same question is there. The same question is there, but you have to find the coefficient of friction, right? So you have to find the coefficient of friction and see how you can find the coefficient of friction from the earlier data. You know phi is equal to 40.245 and epsilon is equal to 1.65. Just remember this 40.245. Okay, so from here phi is equal to 40.245. This is the phi from the previous question that you have solved. This is the value of rake angle. Okay, and in this question it has been told to assume the merchant's theory. So you have to assume the merchant's theory and find the answer. Tell me the answer. Tell me the answer. Coefficient of friction. How you can find the coefficient of friction? Point 0.46. Okay. Anybody else? B. Okay. Shivam has told B option. Asis has told B option. Okay. Yes, option B is correct. I have verified. I have checked with the calculator. I have verified everything. Option B is correct. So see, merchant theory you have to assume. So from merchant theory, we know that 2 phi plus beta is equal to 90 plus of alpha. Okay. Now see, beta is what? Beta would be 90 plus of alpha. Alpha is 15. Okay. So 15 minus of twice phi. Okay. So phi is your 40.245. So when you will calculate this beta, it would come around, uh, let me tell you. So beta would come around 24.51. Okay, so beta would be 24.51. So this is your beta, and the mu is equal to tan beta. Okay, we know that mu is equal to tan beta, so this is nothing but mu is equal to tan of 24.51, which is mu is equal to 4.55, 0.46. Okay, this is your answer. Good, good. Now see, same question is there. In this question, percentage of total energy dissipated due to friction at the tool chip interface has been asked. Now I have told you how you can find the percentage of frictional power or of shearing power or of total energy dissipated. See, these things, these concepts are there. Please try to solve this question and find the answer. Okay, same question is there, same data linked questions are there. GATE Mechanical 2006 questions is there. Okay, solve this. मजा आ रहा है कि नहीं, क्वेश्चन को सॉल्व करने में मजा आ रहा है कि नहीं, आर यू फीलिंग वो जोश आ रहा है कि नहीं, मजा आ रहा है कि नहीं, लग रहा है कि हाँ यार गेट का प्रिपरेशन कर रहा है, आर यू एनर्जेटिक? हाँ, लेट मी नो. Same question is there, and you have to find the percentage of total energy dissipated. Okay, see, just a small hint, percentage of total energy dissipated due to friction. So it is asking that frictional percentage of frictional power. Okay, so frictional power, they're asking about frictional power. So how you can calculate the frictional power? That is nothing but F into chip velocity. Okay, and this is FC into cutting velocity, and multiplied by 100 you will get the answer. Okay, so you have to see the find the value of F, chip velocity, frictional force you have to find, chip velocity you have to find, cutting force and the cutting velocity. These things you have to find. Shivam has told option A, 30%, correct. Tell me the answer. Okay, A, 30%. Good. सभी लोग करें और आंसर बताएं. इंद्रजीत A, okay, good. Yes, so see, you have a relation as R is equal to T by TC, which is equal to VC by V. Okay, so you know the value of R. Okay, so that is something which is 0.7142. Okay, so VC by V is equal to 0.7142. Okay, so this value you have got, VC by V is 0.7142. Now what you need to find? Cutting force is given as 1200 newtons, so this is the cutting force. Next is frictional force. So how you can find the F? How you can find the F? Tell me. How you can find the value of F? See, the value of f is equal to fc sine alpha plus ft cos of alpha, right? And alpha value is what? 15 degree. Alpha is 15 degree. So fc is what? Fc is 1200 Newton. So 1200 sine is 15, ft is thrust force, that is 200, cos, that is 15, and from here the f value is going to be equal to 503.77 Newton. Okay, so just put these things in your frictional power relation. And f by fc, what is f? F is 503.77 by cutting force, that is 1200, and this 0.7142. Okay, so just solve it. Yes, Mukta, correct. Correct. Your reply really gives me a track that okay, you guys are understanding whatever I am giving to you. You are understanding the things. Okay, so this whole into 100 you have to do, and that is the prox, that is getting us 29.998. So that is something about 30%. Clear? So option is A. I hope you all guys have understood what I am trying to explain you. Okay, these questions are very good. Now try to solve this question. Okay, so there might be a problem. Just give me 1 minute. Otherwise you will be like shouting, sir dikh nahi raha hai. Just give me 1 minute. आई एम ऑल्सो ह्यूमन, मेरे से भी गलती हो जाता है, सो प्लीज क्षमा कर दें मुझे. ओके, प्लीज सॉल्व दिस क्वेश्चन. Please try to solve this question and tell me the answer. Tell me the answer. See, orthogonal cutting operation, fine, is being carried out in which uncut thickness is this. Okay, so this is T, 0.01. Okay, cutting speed is 130 meter per minute. Still okay, so I am getting the answers as 0.44. Okay, great. Okay, so I should give more time to you to solve the problem, or should I solve it? Let me explain the problem first. So this is the uncut chip thickness, and this is the cutting speed, that is 130 meter per minute. So cutting speed is given as 130 per meter per minute. Rake angle is 15 degree, so rake angle is a 15 degree. Okay, width of cut is 6 meters, so you width of cut is your 16 meter is there. It is observed that chip thickness is this. Okay, cutting force is 60 newton, so cutting force you write 60 newton, and the thrust force is 25 newton, so thrust force would be 25 newton. Ratio of frictional energy to the total energy, so again frictional energy with the total energy, right? Frictional energy by total energy, so what is the frictional energy? That is fc, sorry, f. Okay, that would be f into chip velocity vc and fc into v. Okay, so this is the basic funda. You have to calculate in this way, you have to calculate the things. And again see, r is equal to what? R is equal to t by tc. Okay, which is nothing but vc by v. So vc by v would be t by tc. What is t? T is 0.01, and tc is this 0.015. So this is the relation of vc by v. So you can just put it here. Okay, and the value of f you can find it from the this equation, that is f is equal to fc cos of sine of alpha plus of ft cos of alpha. Clear? So from this relation you can find the value of f, and your cutting force is already given. So I hope you will be able to find the answers. Okay, any doubt till now? Till now, if you have any doubt, then please ask with me. Okay, I'm waiting for your doubts. If you have any doubt, please ask with me. Okay, so this is the value of vc by v. Okay, so just put it here. So this would be f is 60 newton, fc is going to be your 39.677, vc by v, so vc by v is going to be your 0.01 by 0.015, right? This is the things. So from here when you will calculate it, that would come around 0.4408. So you have to correct up to 2 decimal place. So correct up to 2 decimal place, that is the answer would be 0.4. So you just write the answer as 0.44. Clear? Okay, so now please tell me this answer. Primary tool force used in calculating the total power consumption in machining is? Please tell me the answer of this question. B. ओके, अवस्थी साहब सही आंसर दे रहे हैं. Tell me the answer. Very easy problem is there. B. Okay. See, in this question, it is asked that primary tool force used in calculating the total power consumption. Sir, this word total power consumption. See, the main point is this, tangential tangential force accounts for 99% of power consumption. Okay, power consumption. So this is the thing, that tangential force accounts for 99% of power consumption, and the tangential force comes as, cutting force. Okay, cutting force. So this thing is most important. Option B is correct. Okay, see, Asis, this is clear to you, Asis? I have explained you. Tangential force means what? Tangential force means what? See, in this question, the examiner wants to ask that. See, options are given. See the options: radial force, tangential force, axial force, frictional force. See, axial force is what? It cannot be there, right? Because this is feed force. Okay, so it cannot be account so much of big power. Radial force, it is very small, we have seen. And tangential force, in this there is a cutting force, right? In this there is a cutting force, and this cutting force is actually accounts for 99% of power consumption. So I hope, Asis, this problem is clear to you. Okay, any other doubt? Any other doubts you have? Please tell me the answer. Power consumption in metal cutting is mainly due to, what are the reasons due to which power consumption in metal cutting happens? Tell me the answer. Okay, Kiran A, Asis A. Yes. So see, again the same question is there, that the the examiner has just changed the way of asking the questions, but main gist is same, right? So that is why I am always trying to say, the tangential component of force is going to be your answer, right? We have understood the concept. So again I am just writing the most important point, that concepts are limited. Okay, so concepts are limited. So if you could practice the previous year GATE plus ESE papers, okay, and if you would enroll in any test series, believe me, this is going to give you a score great score. Okay, so try to use these things. Concepts are limited. The more you will practice, the more you will understand. See, these are like old questions. See, this is the old questions are there, these in this old questions are there, and in test series new, okay, new questions, or just another tricky questions you will get, right? So this test series will open your mind. This test series will open your mind. So this is the most important point. Concepts are limited, so just practice these things and you will be able to score great marks. Okay, please tell me this. Please try to solve this question and tell me the answer. Please try to solve this question and tell me the answer. See, in this question, see, in this question, forces acting on a finished turning tool, right? So we have seen, the for a turning tool there is cutting force, right? And there is the axial force, okay, and there is a radial force. Okay, these things are there. Mukta, okay, fine. What answers they have given? D. Okay. Kiran, C. Okay, C. uh, See, you have the problems. See, you have the problem to understand this question. See, there is a comprehension problem. See, for a turning tool, this is a cutting force. Okay, this is an axial force and this is a radial force. Okay, see, FC is cutting force. Clear? So this is your FC. Axial force is what? Feed force. So this is your axial force. But radial force, here it is given as thrust force, so this is nothing but this is radial force. And in earlier slides I have told you that FC is going to be greater than F feed force, or axial force is going to be greater, and then radial force. This is the sequence, right? So 3 is going to be greater, this is 3. FF, that is, this is going to be 1, and FR is going to be your this thrust force, that is 2. So 3, 1, 2. Option C is your correct answer. C is your correct answer. Till now, if you have any doubt, please ask with me. If you have any doubt, ask with me. And try to solve this question. Try to solve this question. Point 2 sine 60. Okay. Tell me the answer. Are you sure that should be 0.60? Kiran, please check. Please check it. My goodness, आप लोग खिचड़ी पका चुके हैं. See, very easy question is there. Okay, I'm giving you some more time, just 20 seconds. Give me the answer. See, this is GATE 2014 previous year questions. See, very easy questions are there, but yet these are very tricky for you guys, that because of the problem that you cannot understand that question. Yes, yes, Asis has given the correct explanation. Let me explain it. Okay, see, a straight turning operation is carried out using a single point cutting tool. Okay, and the feed is zero point 0.2 mm per revolution. So feed is given as 0.2 mm per revolution, and the depth of cut is 0.5 mm. So depth of cut is 0.5 mm. Tool has a side cutting edge angle of 60 degree. So see, side cutting edge angle of a tool is 60 degree, that is CS. Fine. So this angle is 60 degree, and this angle is lambda, which is 30, which is going to be your 30 degree, right? Because this is approach angle, right? Uncut chip thickness, right? Uncut chip thickness, they are talking about the uncut chip thickness. How can you find the uncut chip thickness? So you know that T is equal to F sine lambda. Okay, so what is T? So T is the uncut chip thickness. F is what? F is given as 0.2 sine lambda. Lambda is going to be 30. So from here your answer is going to be 0.1. Clear? Clear everyone? This question is clear to you? This question is clear to you? So this is what is from my side for today. If you have any doubt, then please ask me. I am open for your queries, as well as please ask the questions if you have any doubt. And if anybody is interested to for the plus subscription, if his colleagues or peers or anybody is in own network, then please share this code SIRVK. You will get a 10% off, as well as a personal mentorship from my side. So one more thing that I want to add here is in this Unacademy learning app, tomorrow would be the 11 a.m. I will take the class of strength of material. This is going to be stress and strain. Part 2 would be there, because today I have taken the part 1 and the duration would be of 2 hours. Okay, so you can assess. We will cover tomorrow. Tomorrow I will try to cover some more questions also, as well as if time permits, then I will start the tool. Okay, tool chapters, I'm going to start the tool chapters. In that tool chapters there is a Prater wear, tool wears are there, how many types of wears, machinability, Taylor's tool life equations is there, economics of machinings are there. And once the tool life is complete, your machining is complete. Okay, your metal cutting, machining, everything is complete. It's like your first chapter, I think metal cutting is totally completed. Okay, so I think within 4 classes would be more than enough. I explain you everything in great details, so that there should not be any confusion or there should not be any doubt. Even if I give you a lot of practice questions are also there, try to solve these questions also in your home. And you did not need to do some more hard work, whatever I am giving to you. So thank you so much. Any other doubt, please attend my lectures at Unacademy learning app also tomorrow 11 a.m. And if anybody is interested, they can use my code SIRVK. If you have any doubt, then please ask. Otherwise I am going to end the session. Okay, so I assume that you don't have any doubt. Thank you so much for your active participation. It really feels me happy if I have taken a class and people are saying that is no doubt is there, right? So I'm just lucky that I have tried to clear your every doubt. So thank you.